Yes. So after having a clear picture of the Lagrange's mean value theorem as well as the Cauchy's mean value theorem, we are in a position now to go to the generalized case of both the mean value theorems. Okay. So this is now the generalized mean value theorem as it is recommended or suggested or proved the statement by the Taylors. That's why it is also known as the Taylor's theorem, or which we are going to take on now for the Lagrange's form. Okay, so now here is here what is how the statement is going on actually. If f be a function defined in the closed interval AB, and the condition says that if n minus 1th derivative of the function f, that is f of n minus 1, is continuous in closed interval AB, and second one is nth derivative of the function, that is fn, is derivable in open interval AB, then there exists a point C, obviously lies between A and B, belongs to AB, or lies between A and B, such that we can write the expansion as f of B equals to fa plus b minus a into f dash a plus b minus a whole square by 2 factorial into f double dash a. Similarly, going on like this, if I go for n plus 1th term, or the last term over here will be b minus a to the power n by n factorial fn, that is nth derivative at the point C, nth derivative of the function at the point C. And this last term, which is after the nth term, this is actually the n plus 1th term. And this term is also have a special notation, that is Rn. We can write it as b minus a to the power n by n factorial into fnc, derivative, nth derivative at the point C, nth derivative of the function at the point C. This is known as a remainder, or else, since we are doing the Lagrange's case, so I can specify it as Lagrange's form of remainder. Lagrange's form of remainder after n terms. Lagrange's form of remainder after n terms. Right? Now again, this is the Lagrange's form of remainder after n terms when we are considering the interval AB. Now if I go for the H theta form, in H theta form, what it will be there? B is replaced by some A plus H and C is replaced by A plus theta H, where obviously 0 less than theta less than 1. So here, how the expansion will go? FB means FA plus H equals to FA plus B minus A means H. So H F dash A plus H square by 2 factorial F double dash A plus going on like this. The n plus 1th term will be H to the power of n by n factorial Fn. C is what? A plus theta H. So this is the H theta form. Now here if I am going to write the remainder after n terms, then Rn becomes H to the power of n by n factorial Fn A plus, sorry, this is A plus theta H. All right. So this is the Rn in H theta form. Now, one more form is there, that is Maclaurin's form. Okay. So in Maclaurin's form, what else? What the modification is there? That is in H theta form. If I put A equals to 0. Okay. And let us take A equals to 0 as well as H equals to X for your easiness, nothing else. Otherwise, you can keep it as H also. And X equals to X. To make it as a function of fx, nothing else. Okay. So what it will be then, if A plus H becomes fx equals to fa becomes f0 plus x f dash 0 plus x square by 2 factorial f double dash 0 plus going on like this, the n plus 1th term will be x to the power of n by n factorial fn theta x. All right. And here now Rn will be the Lagrange, the remainder after n terms, Rn in Maclaurin's form, it will be x to the power of n by n factorial fn theta x. So we have found for Lagrange's mean value theorem, according to Lagrange's, the remainder after n terms, whenever I am considering the interval AB, it will be like this, Rn. It will be modified to h to the power of n by n factorial fn a plus theta is in h theta form. And it will be modified to x to the power of n by n factorial fn theta x in Maclaurin's form. Clear? So all the forms we have taken in LMVT and all the forms we have generalized and we have obtained Rn, that is Lagrange's form of remainder after n terms, in the 3 forms that we have learnt in LMVT. Okay. Yes. So after taking the generalized mean value theorem in case of Lagrange's form, now we are moving on to the same generalized mean value theorem for Cauchy's form. Cauchy's mean value theorem case. Okay. So firstly, the conditions remains as it is, that is n minus 1th derivative fn minus 1 is continuous in closed interval AB, and second is nth derivative fn exists in open interval AB, right? So what will I write to get the point C? If this happens, then there is a point C which lies between A and B, such that FB equals to f of A plus B minus A into f dash A plus B minus A whole square by 2 factorial into f double dash A. Likewise going on, the last term will be B minus A into B minus C to the power of n minus 1 f n C divided by n minus 1 factorial. So this is your Rn now. So remainder after n terms over here, that is Rn, will be B minus A into B minus C to the power n minus 1 fnc. This thing, only this much thing you need to remember, you need to learn. If you know this, you can derive the other form also. Divided by n minus 1 factorial. Okay.
Hello, ma'am.
Yes. Anyone is
Ma'am,
saying something?
you went mute for the last 10 seconds.
Okay, wait a little bit. Is it okay now?
Now it's okay.
No, it's okay. Okay, fine. So what I have told in last 10 seconds as maybe I got mute. I don't know how. So the conditions are there as we have seen in Lagrange's form also. Then we will be writing it as fb equals to fa plus b minus a f dash a, b minus a whole square by 2 factorial f double dash a. Only the last term, which is the n plus 1th term, that will differ in Cauchy's. That is, it becomes b minus a into b minus c to the power n minus 1 by n minus 1 factorial and fn c. Okay, so Rn, which is the remainder after n terms, in this case will be b minus a into b minus c to the power of n minus 1 by n minus 1 factorial fn c. Similarly, if I go for h theta form, then what happens? Obviously, your b will be replaced by a plus h and c will be replaced by a plus theta h. So let us do that only in the expansion. So fb means f of a plus h equals to f of a plus b minus a means h, f dash a plus h square by 2 factorial f double dash a plus going on like this. B minus a means h. The last term I am writing. B minus c. This I need to write. B minus a plus theta h. And b will be what? Actually, I need to replace b also. In h theta form, no b is there. B is replaced by a plus h. A plus h minus a plus theta h, that is c to the power n minus 1. Fn, c means a plus theta h divided by n minus 1 factorial. So if you simplify it a little bit, you will come out with Rn as here. Your Rn will be h into, how much is this? A get cancelled and we are left with h minus theta h to the power n minus 1. So if I take h common from there, I will be getting h to the power of n minus 1. And h is remaining outside. One more h is there. So it is actually h to the power of n into 1 minus theta to the power of n minus 1 divided by n minus 1 factorial remain as it is and multiplied by fn a plus theta h. Is it okay? How I have written Rn?
Yes, ma'am.
Okay. Now after h theta form, one more form we will be having, that is Maclaurin's form. In Maclaurin's form, what will I do? Just I replaced a equals to 0 in h theta form. Okay, so let us do that. And x equals to h. They have done that to get a function fx form. So after these replacement, what it will be? Fx equals to f0 plus x f dash 0 plus x square by 2 factorial f double dash 0 plus going on like this x to the power of n 1 minus theta to the power of n minus 1 by n minus 1 factorial into fn a plus theta h, a is 0, so it is theta x, fn theta x. So here your Rn is this one. Your Rn becomes x to the power of n 1 minus theta to the power of n minus 1 by n minus 1 factorial into fn theta x. All right. So in all the cases, we have seen the remainder after n terms for the generalized case of Cauchy's mean value theorem. Right?